Hey class, Mr. Bean here. I've been asked to make a video of our theory behind lab 1.4 today we did in class. So we'll go ahead and kind of discuss it here and let people kind of get caught up here. All right, so I'm gonna go ahead and use pin here. Okay, so I'm in the pin mode. All right, so we talked about gravity. So if I have an object here, right, like this here, and I let it go, it's going to obviously fall in this direction here. Okay, so this is going to be it's going to fall because of an acceleration due to gravity. It's actually force of gravity, but it has an acceleration associated with it here on the Earth. So it is a vector quantity, and we'll go ahead and say negative 9.8 right meters per second squared. Okay. Okay, so that's a vector. Now, what happens if it's so let's now suppose we have a ramp. So let me go ahead and use black here. So let's say we have a ramp here, and we take this ramp, it's like this here, okay, and make it kind of like so here. And so we know that this here is 90 degrees. So now we take our same box here, and let's say I put it right here. Okay. Now we do know that if I put it right here and there's no friction, it's going to slide down the ramp here. Okay. So now gravity goes straight down, but what's causing it to go, or what's the acceleration down the ramp here? Well, it's a component of gravity. Okay, not the full 9.8, but a component of it that's going to make it come down the ramp here. Okay, so when we set this up, it's going to use green here. So we know that we use green. Okay, so we know let's take a look at this in more detail. So here's a triangle. I'll go ahead and make this here theta. Here's angle theta here. And this is from this perspective here. Okay, I'm right here looking at it. And let me make that a little bit better. So this is theta. Okay. And so this here, I'm going to go ahead and put two of them here. So this angle here is going to be 90 minus theta. Okay, like that. All right, so let's go ahead and take a look at this here. So now we're gonna pretend it's right here. This mark here is where we're gonna do all of our forces and acceleration vectors and whatnot. So I'll go ahead and use pink here. Okay, so gravity is going to go straight down. We'll go ahead and put pink right here, and it is going straight down. And this is our This is our vector gravity. Okay, okay, that's the main vector right here. Now we're going to do components. Okay, let me go ahead and do orange here. Now there's a component right here, and I'm going to split this in components here. This component here, this is going to be gravity, but it's going to be perpendicular. It'll be perpendicular to the ramp here. Okay, and let me go ahead and use let's use purple here. Now there's another component here. I'm going to go ahead and kind of go like this here, and this component here, this component of gravity we'll call parallel. Okay, because this vector is parallel to the ramp here. Okay, and if I look inside here, this should be square root here. And now what happens in most textbooks, they'll tell you that this here is theta. Okay, so if this is theta, so this theta and this theta are the same. The question is, how do they get that? Okay, which is a very good question. Okay, now in order to figure out why this is theta, so we can progress further, is let's go ahead and draw some lines here. We'll go ahead and let me use yellow. Okay, so let's say this is a line here, and let me make a line right here as well. Okay. So these two lines, these are two transverse lines here, or excuse me, two parallel lines, and this here is the transverse. Okay, so let me go and use green here. So if this is two lines, two parallel lines, this is the transverse, alternate interior angles are congruent. So I'll go ahead and put it like this here. So this is congruent to this. And these here are vertical angles. So I'll go ahead and put here like this to show this is equal to this, which is equal to this. So if this is 90 minus theta, and this here is 90 degrees, if this is 90 minus theta, then this has to be theta here as well. Okay, so this is theta here. Okay, all right. So Okay, so this is theta. So this angle right here. So this is the perspective here I'm looking at. We're right here. Okay. Okay, I'm right here. So this purple component here, okay, this purple component here is going to be it's going to be what G is, magnitude G, and it's going to be the sine of theta. Okay, so that means that this vector I can move up here. Okay, let's go ahead and do clear here. Oh, geez. Oh man. Can I redo that? Oh boy. Okay. Anyways, so here's my triangle here again. Okay. So what the outcome is that if I'm here, then this vector here, so we'll call it accelerate. Okay, it was G parallel, and that's going to equal, we'll call it acceleration. Uh, hold on, acceleration. Oh man, hold on. So this is G parallel, and that's going to be acceleration down the ramp. Okay, down the ramp, and that's going to have a value of G times the sine of theta. Okay, man. Is there a way back? Let me see. Let me do back. Uh, oh man. Oh boy. Yikes. See, can I go back here? Let's do mouse. Uh, oh man. Okay. All right. So anyways, so that's how we get acceleration down the ramp is G sine of theta. All right. Thank you for listening.